Now we are going to take up the topic that is the electrochemical cell, right? As you already know that electrochemistry is a branch which just deals with the conversion of electric energy into chemical energy, and simultaneously we can have the chemical energy into electric energy, right? So we need a device in which this kind of electrochemical change can be carried out, and that is the electrochemical cell, right? So that means electrochemical cell is actually a device in which electrochemical change can occur, right? So depending upon how the arrangement is there, electrochemical cells are basically of two types, right? One is an electrolytic cell and the other is the galvanic cell, right? So first of all, you should know that in these cells which kind of conversion occur, right? So in electrolytic cell, electric energy is converted into the chemical energy. By looking at it, it should be clear that we will be applying an external source of current, and for this, due to that external the source, the chemical reaction will take place, right? And what happens in case of the galvanic cell? It is just vice versa of it. That means the chemical reaction will take place and it will lead to the production of electric energy. That means here we don't need an external source of current. Automatically the chemical reaction will occur and they will just produce the current, right? So just see how it produced. So again, I am just repeating, it is a device in which the electrochemical change can be carried out. Electrolytic cell, it is a type of electrochemical cell in which electric energy gets converted into the chemical energy, and galvanic cell is the cell in which the chemical energy gets converted into the electric energy, right? So just first look at that, what is the electrolytic cell and how it works. Electrolytic cell consists of a beaker, right? So this is a beaker, or you can say it is an electrolytic cell, right? So what does it contain? It contains a solution, that is, it contains an electrolyte. Electrolyte is actually a substance which will lyse on passing the electric current. That is, the name suggests it is electrolyte. That means electricity is passed and it gets lysed. So that is why it is called as an electrolyte, right? So what do we have in it? We have the electrodes, that is the source of the current. You can say these electrodes will actually pass the current into the solution. These are called as electrodes. They are mostly form of graphite, that is the form of carbon mostly, and they are connected by means of wire to the battery. When I indicate two lines, it specifies the battery, right? The bigger line corresponds to the positive terminal and the smaller lines corresponds to the negative terminal, right? So the electrode which is attached to the positive terminal of the battery is positively charged. That means it acts as anode. It is the name of the electrode, right? We have electrode 2, again I'll write for you the positive and the negative one, depending to which terminal of the battery they are attached to. If they are attached to the positive terminal, it acts as anode. If it attached to the negative terminal, it acts as cathode, right? So similarly, it acts as cathode, that is the negatively charged terminal. So this kind of apparatus we have in electrolytic cell. Again I'll repeat, this is the cell, this is the electrolyte, the solution which will be lysed on passing in a current. Electrodes connected by means of wire to a battery, positive terminal, that is positively charged anode, negative terminal negatively charged, that is cathode, right? So suppose, just to make you understand, I am considering an electrolyte to be AB. Just to we'll be doing in detail with the specific examples, but just to make you clear that how this electrolytic cell actually works, because you must be curious to know that how this apparatus is going to work. So that is why I am considering an example that is AB, right? So it is a good electrolyte. So what happens? When the current is switched on, I will put a key also. So when we will switch on this current, that means circuit gets completed and the current flows through the electrode into the electrolyte, and this electrolyte gets dissociated. Like this, right? That means this form positively charged ion and this form negatively charged ion. Now, what will be the fate of these ions? This positively charged ion will move to the electrode of the negatively charged electrode. That is you know that the opposite charge attract each other, right? So that means the oppositely charged ion will obviously go to the electrode which will carry the opposite charge. That means it will go to a negatively charged electrode, that is the cathode. and this negatively charged ion will go to the positively charged electrode, that is the opposite one, that is the anode, right. So they will move to, you can say we have AB here, right, A positive, B negative, this positive will move to this side and B will move to this side. So this reaction, or you can say the process doesn't end here. On moving to cathode and anode, they perform certain reaction, they get a change in themselves. So just see what kind of change happens when they move. So what happens at cathode? So what kind of reaction occur at cathode? When this A positive, as you can see, move to cathode, that means this is positively charged ion, that means it has lost its electron. And how many electrons? It is equal to the number of charge it possesses. So as you can see, there is only one positive charge, that means it has lost one electron. So here it will just gain its electron back which it has lost earlier. So that means because it has lost one electron, so it will gain one electron and will turn from ion to atom. So this is actually a gain of electron, that is the reduction. So reduction occur at cathode, right. So what happens in this thing anode now? So what kind of reaction happens at anode? What migrate to anode? Obviously you can see B negative migrate to anode. So that means this B negative, why it is B negative? Because it has gained electron. How many? It is equal to the number of charge. So as you can see, it has only one charge. So that means it has gained one electron. So what it will do at anode? It will just you can say give back the electron which it has already accepted. That means one electron and will leads to the formation of B. So that means the oxidation, loss of electron, that is the oxidation occurs at anode, right. So this is the kind of, you can say, the reactions that occur in the electrolytic cell. As you can see, we pass electric energy and this leads to the conversion of this chemical energy. So that means it is a cell which deals with the conversion of electric energy into the chemical energy. I think it's clear now, right. So this is how the electrolytic cell actually work. Now let us concentrate on this galvanic cell. As I told you, it is a cell which works in opposite manner to the electrolytic cell. That means it converts the chemical energy into the electric energy. It was converting electrical into chemical, it will be converting chemical into electrical. That means we don't have to use any battery or cell in this case, because it will produce the current at the cost of chemical reactions occurring in it. So just see that what is the apparatus used in the galvanic cell. It consists of two beakers, right. It contains the electrolyte and even it contains the electrolyte. Suppose I am taking an example of zinc copper galvanic cell. So this is zinc rod and the electrolyte we are using is 1 molar ZnSO4 solution, right. So similarly here we are taking copper rod dipped in 1 molar copper sulfate solution. So this is how, but they are not present separately, they are connected with each other by means of a metallic wire, right. As we know that it is going to produce the electric energy, that means we need an instrument which can just show that the electric energy is produced. So that is why we have put galvanometer here, right. Do you know what is galvanometer? You must be thinking that ammeter is a device which is used to measure the electric current, but in this case I am using the galvanometer. So what is the difference between the galvanometer and the ammeter? Ammeter is an instrument used to measure a high amount of current, and galvanometer is an instrument which can even measure a very small magnitude of current as well also. So that means in order to just find this minute amount of current which is generated as a cost of chemical energy or a chemical reaction, we need a galvanometer because it is sensitive, very sensitive, and it can even show the deflection on the production of the small amount of current, right. So that is why I am using the galvanometer here, and I have just used the key also, right. So this is the apparatus. It is not all done. We have a you can say a different, you will get to see a different thing in it. These two solutions are also connected with each other by means of this tube, U-shaped tube, and this is called as salt bridge. It is actually connecting the solutions and the solutions. That means it is just completing the circuit. As you can see, the external circuit is connected by means of wire. It is also connecting the solution, and it do serve as a important use, that it makes the solution electrically neutral and just keeps the cell performing its function. But how, we'll be taking up later. So for this moment, because we just need to differentiate between them, that what kind of structures they possess, we'll be discussing the functions later, but for this moment just go through this figure, right? So again I'm repeating, there is two cells, one cell containing zinc rod in ZnSO4 1 molar solution, other copper rod in CuSO4 solution. Solutions connected by means of U-shaped tube, that is the salt bridge, which carries the inert electrolyte. Function we'll be discussing later, right? So first be thorough with this figure. And this is the wire, and this is the galvanometer, right, and it is the key. So this is the, you can say, apparatus which is used in a galvanic cell, right. Now as we saw that what kind of reactions occur in this, we'll be seeing just, we'll have a look here also, not in detail because we'll be doing detail after completing these kind of cells, but for this moment I want to tell you that you must be curious to know that what kind of reaction occur, like if the reaction occur in this is this, and what kind of reaction occur in this, right. So what happens? Out of this zinc and copper, the one which has the more power to get oxidized will get oxidized. That we decide on the basis of the value of the electrode potential. Now you must be thinking, what is electrode potential? That is what I want to tell you. We will be discussing in the later topic. So for this moment, just I am using this word, like out of two rods, which rod will have the maximum tendency to get oxidized will lose the electron, and the one which has less you can say the ability to get oxidized will get reduced in this case. Right. So the one out of them which is, you can say, a powerful reducing agent or which has more tendency to get oxidized will lose the electron, and the one will be the first one to initiate the chemical reaction. So out of zinc and copper, it is the zinc. So that means zinc will lose electron and it will turn into Zn2 positive. What will happen now? This you know that this thing, what is occurring? Oxidation is occurring, right? These two electrons will flow from these. It is not only the two electrons, because it is the two electrons are liberated from one zinc atom, right? We have so many zinc atoms which are getting oxidized, so that means it leads to the generation of numerous electrons. So these electrons are traveling from this wire to this, and when they travel, they just indicate the deflection in the galvanometer. That means the flow of electron that is constitute an electric current, right? So what is happening? This key is joint. When this charge is just moving, this is reaching the copper, right? And as I told you that out of zinc and copper has a tendency to get reduced. So it is just gaining two electrons and again forming the copper atom, right? So this is how this kind of reaction is occurring. So that means what is occurring here? Reduction is occurring. So this you can see that this galvanic cell just perform this kind of reaction, or I can sum it in this way also. ZnCu2 positive give rise to Zn2 positive plus Cu. So the one half cell in which oxidation is occurring is called as oxidation half cell, and the one in which reduction is occurring is called as reduction half cell. As you can see that in a similar beaker, oxidation and reduction were occurring, right? But in them there is a separate beaker for the oxidation and the separate beaker for the reduction, right? So this is actually the difference between them, that how they work, and I think you are clear with the cell now, that is the electrolytic and the galvanic cell, right? Now what is the basic difference between these two cells, right? The first difference is that it actually converts electric energy into chemical energy, and it converts the chemical energy into electric energy. It is clear to you, right? It consists of one beaker and it consists of two cells, or you can say it consists of one cell and it consists of two cells, right? Now, when this kind of reaction occurs, heat is produced, but in this case, no heat is produced, right? And moreover, in this case, you get to see that there is no production of electricity, or you can say there is no electric current produced. But as these reactions occur, they lead to the production of electric energy, right? And these reactions go almost to completion, but these reactions do not undergo completion. They go on working because one is getting oxidized at the same time, other is getting reduced. So these reactions do not go to you can say the complete completion. They just go on occurring, but doesn't get the reaction won't stop here, right? So these are actually the electrolytic cell and the galvanic cell.